Hi everyone, this is example 6 from the supplemental topic involving discrete random variables from your student packet. So it says, consider rolling a die and counting the number of sixes rolled. The first thing it asks is, are these Bernoulli trials? And we would say yes. They're Bernoulli trials for 3 reasons. 1, we either roll a 6 or we don't. Bernoulli's trials only have 2 outcomes. It's a yes or no, you do or you don't type of situation. So yes, these are Bernoulli trials. We either roll a 6 or not. The other reason that these are Bernoulli trials is because the trials are independent. And then the last reason that they're Bernoulli trials is because the probability throughout stays the same. So the probability of rolling a 6 is the same no matter what. All right, so the first question says, what is the probability that the first roll is a 6? Now, I want to point out that in this topic, we're talking about the binomial model. But this is not a binomial question, and it's because we actually have a position for the roll. It says, what is the probability that the first roll is a 6? So if the first roll is a 6, the probability of rolling a 6 is 1 out of 6. So the answer is just 1 out of 6. What's the probability that the third roll is a 6? Well, these are independent trials, so it doesn't really matter if it's the first roll or the second roll or the 10th roll. It's always, the probability of rolling a 6 is always 1/6. Then it says, what is the probability that the first 6 you observe is on the third roll? So again, notice that we are talking about a position of seeing a 6. So this means that we would not see a 6 on the first roll, we would not see a 6 on the second roll, but that we would see a 6 on the third roll. So this would mean not seeing a 6 is 5 out of 6. So we would not see a 6 on the first roll, not see a 6 on the second roll, but then on the third roll, we would see our first 6. If you put this into your calculator, you'll get 0.116. Then it says, what's the probability that you roll 3 6s in a row? 1/6 times 1/6 times 1/6. If you put this in your calculator, you get 0.0046. And then the last problem is a little more complicated, the last question. It says, if we roll the die 3 times, what's the probability that we will see exactly 1/6? So I want you to notice that in this question, they do not give us a position for where we see that 6. Is the 6 on the first roll, the second roll, or the third roll? Well, in this case, we have to count all 3 of those scenarios. So if we figure out the probability of rolling that 6 on the first roll, it's 1 out of 6, and then we don't roll a 6 and don't roll another 6. That's the first scenario. The second scenario is that we roll the 6 on the second time. So now we don't roll a 6, we do roll the 6, and then we don't roll a 6. The third scenario is that we don't roll the 6 until the last roll. So we don't roll a 6, don't roll a 6, and then we do roll a 6. If you put all this in your calculator, notice that each one of them is the same number, but still, if we put this in our calculator, we get 0.3472. But this is actually a binomial problem. And your book goes through the formulas for doing this by hand. But I want to emphasize to you that you should be using the binomial command in your calculator. And there are two commands, the binomial PDF and the binomial CDF. The binomial PDF calculates the probability of seeing exactly of something. So this is exactly 1/6. So the other thing we could do to get this same value is to enter binomial PDF. So you'll go to distribution, so that's at second vars, and you'll go down to binomial PDF. We're doing a total of 3 rolls. The probability that we roll a 6 is 1/6, so that's the probability of success. And we are looking for the probability that 1 out of these 3 is a 6. And if you put this in your calculator, you will get the exact same answer.